Hello everyone, Mehdi is here. I took DAT 2 days ago and I thought to make this video to show you how to do the hole punching. I came up with my own approach which helps me to do these hole punchings very fast, and then I can spend more time on the more complicated sections like top, front end and angle ranking. Anyway, first of all, on the DAT test, they give you a laminated paper which looks very similar to this. It has small squares on it, which I found really helpful. What you should do is that during the 15 minutes tutorial, you should draw your grids for the hole punching section. So here's how I do this. I draw two horizontal lines. I first count 4 small squares, and then I draw a horizontal line all the way from the left to the right of my paper, and again I count 1, 2, 3, 4 small square and draw another horizontal line, and then I count 4 squares and draw a vertical line. Again 1, 2, 3, 4 small square, draw a vertical line. Again 1, 2, 3, 4, 1, 2, 3, 4, and so on. By doing this, you end up with 16 or 18 square depending on how big is your laminated paper. You can use these grids or squares to solve the hole punching problems. Okay, here is how I do these problems. Let's look at this particular problem. Okay, you always start from the figure on the far right, and then you put X's in your grid corresponding to each circle. You need to practice to, just by looking at the figure, you know where these circles are located corresponding to your grid. So here we have 2 circles. So we put 2 X's in our grid corresponding to these 2 circles. Then you look at the 2 previous figures, and then you need to find the axis of symmetry over which this figure has been folded to get this figure. And just always remember, you can find the axis of symmetry when you're comparing 2 figures in the figure on the right. So the axis of symmetry would be either this line or this line. So by comparing these 2 figures, it's obvious that this is the axis of symmetry over which this figure has been folded to get this figure. So basically this part of the figure has been folded over this axis of symmetry to get this figure. Okay, then what you do is you draw this axis of symmetry in your grid. To find the location of this axis, you can just look at the figure below this one. So see, this axis of symmetry is going through this part of your figure. So we draw the axis of symmetry, which would be right here. Then what you do is you reflect all of the excess on this part of your figure over this axis of symmetry. So you only need to reflect the excess on this part of your figure. So you reflect this X and then this X over this axis of symmetry. Then again, you look at this figure, the last figure on the left, and usually it's easy, very easy to find the axis of symmetry in this figure in the last one, and you can see that the axis of symmetry here is this one, and this part of figure has been folded over this axis of symmetry, and then we get this figure. So what you need to do is, again, you need to draw this axis of symmetry in your grid. Again, you look at this figure at the bottom, you draw the axis of symmetry, and then you reflect the excess only on this part of your figure, only on this part of your figure over the axis of symmetry. So you reflect this x and then this x, and this gives you the result. So the answer would be A. Now let's do another problem. Let's look at this figure. Okay, so we use, oops, I guess we don't have enough space here. Okay, so you use the second grid that you made to solve this one. Okay, again, you start from the figure on the far right. You put an x corresponding to the circle, which would be this part of your grid. Then you look at the two previous figures and try to find the axis of symmetry over which this figure has been folded to get this one. So again, like I said before, you can find the axis of symmetry when you're comparing two figures in the figure on the right. So one of these are the axis of symmetry, which with comparing these two is obvious. This is the axis of symmetry. So basically, this part of this figure has been folded over this axis to get this figure. So again, you draw this axis of symmetry in your grid, and then you reflect the excess on this part of figure over this axis of symmetry, which would be this one. Then you look at the two previous figures again. So first you start with the one on the right, then these two figures, then to compare these two to find again the axis of symmetry. Here again, when you're comparing these two figures, you can find the axis of symmetry in the figure on the right. So one of these are the axis of symmetry. By just looking at the figure, you realize that this one is the axis of symmetry. It's like we have folded this part of this figure over this axis of symmetry to get this one. So you need to reflect all the excess on this part over this axis of symmetry. So you draw this axis of symmetry in your grid and then reflect all the excess on this part over this axis of symmetry. Then you look at the last figure and it's easy again. You can find the axis of symmetry is this one. So it's right here. And then you need to reflect all the excess on this part over the axis. So all the excess on this part over this axis. So we don't have any excess in here. So basically we are done, and the answer would be this one. Now, problems can get a bit more complicated, but again, using this method, you can solve, I would say, like 90-95% of the problems without spending too much time. Okay, let's look at this problem. Okay, what you need to do in every hole punching problem is that when you're looking at the first figure on the right, look at the circle, look at the hole, and make sure that you have paper on the location of the circle in all previous figures. So here the circle is here, and this figure we don't have the paper, but here, as you can see, where we have the hole, we don't have any paper. So when this happens on your grid, you should put a circle. That's what I do. You put a circle rather than an X corresponding to the circle and the figure. So here, because we didn't have any paper on this location where we have the hole, we put a circle rather than X. So here is how we treat circles. We reflect the circles, but when we are counting the holes at the end, we don't count the circles in our grid. So let me just do the problem, and you see it's very easy, and like I said, 90-95% of the time it's accurate. So here we put a circle because we didn't have any paper here. Then the rest is the same as before. You look at these two figures, try to find the axis of symmetry. Either this one or this one is axis of symmetry. By looking at this figure, it's obvious that this one is the axis of symmetry, so we draw the axis of symmetry. Then we reflect all of the x's or the holes on this part to this part. So you draw the axis of symmetry, and as I mentioned before, you treat the circle, you reflect the circle over the axis of symmetry. So you reflect the circle over the axis of symmetry, so you would have an X here. Then you look at the next two figures or the two previous figures. Again, try to find the axis of symmetry. It would be one of these three, which again, by comparing these two, you see this is the axis of symmetry. You draw that, and then you reflect all the circles on this part of the figure over this axis. So all the axes and this part over the axis of symmetry. So you have one X here, and then on this figure again the axis of symmetry is this one. So you draw the axis here. Then you reflect everything that you have here on this side over this axis. So you reflect this X, and then you reflect this X. So now, as I mentioned before, when you want to count your holes, you don't count the circles in your grid as a whole. So basically it's like this doesn't exist in your figure. So the answer would be this one. It may sound a little bit complicated, but when you just do it a couple of times, you see you can just do it very easy and fast. Okay, let's do another example to just make it clear. Okay, I guess you can see. Sorry guys, this is my first time making a video, and I know I'm not any good, but I'm just trying to do my best. Okay, so here again we start from the figure on the far right. You look at all the previous figures, and then you need to make sure that where you have the circle there is a paper in all previous figures. We have the paper here, but here again we don't have the paper. So what you do is again you draw a circle in your grid rather than an X. So compare these two. The axis of symmetry is either this one or this one. So it's obvious that the axis of symmetry is this one. So you draw the axis of symmetry here in your figure. And then you reflect all the circles on this part of your figure over the axis of symmetry. So all the circles or X's on this part of your figure over this axis. So you have one X here. Then compare these two. Axis of symmetry is this. So you draw the axis of symmetry. You don't have anything here, so nothing is reflected on this side. Then you look at the last figure. Axis of symmetry is this here. So axis is here. You don't have any X's here. so nothing is reflected on this part. So the answer would be basically, like I said, you don't count the circles in your grid as a whole. So this would be the answer. Let me just see if I can find one more problem to, okay, make sure that you know what I'm trying to show you. Okay, here. Let's do this one. Here we have a circle here, we have a hole here, we have the paper, we have the paper, we have the paper. So we put an X. Then compare these two figures. This is the axis of symmetry. You draw that here, reflect the axis on this part over the axis. Compare these two. This is the axis of symmetry. Reflect all the axis on this part over this axis. And then again on this figure, axis of symmetry. Here, reflect all the axis on this part over the axis. There you go. So the answer would be E. Pretty easy, huh? Well, just let me do the last one. Maybe something a little bit complicated. Well, I guess I don't have any more example here to show you guys, but I hope you got what I wanted to show you. Yeah, I don't have any more example of. Anyway, I guess you got the idea. And if you use this method, like I said, you're gonna be like 90-95% of the time accurate, and the remaining 5% is you just need to think a little bit more. Again, using this method you can get 100% of the time the right answer, but if you just don't want to spend much time on this section and you want to use your time on other sections, you can just use this method and you can be sure that you're getting the answer like 95-90% of the time right. Okay. Yeah, I wish I could find another problem, but sorry guys. I guess I need to be more prepared next time that I'm making a video. Anyway, I can make more videos to show you how to do other sections of PAT, or even, you know, how to study or what to study for other sections like the science sections, math sections. But let's just see if you guys like my video, and you can make just comments, and if I see that you are happy with my videos, I'm gonna make more to help you guys out there who are trying to take the DAT, and I know how stressful it could be, but with just practice and practice and practice, you get better and better and better, especially with PAT. You just need to practice. Anyway, I hope I could help you guys, so leave some comments and let me know how I did and if my video was helpful. Thank you guys and good luck.